Hi, my name is Rado, and today we'll be discussing about how to build an encrypted file system in Rust. This will be our. Sorry. Yeah, hey. So today we'll be discussing about how to build an encrypted file system in Rust. So these are the topics we will be covering today. We'll discuss a bit about how the files are structured, how the fuse works, and how we use it, and what are some key features that we have in the application. This is me. I was a Java developer for many years, involved in a lot of projects with big data, microservices, containerization, and recently, in last year, I switched to Rust, and I'm focusing on cryptography and distributed file system. I managed to be the fifth most active users on GitHub, and given the other four are not using Rust, I'm the first in the Rust category, and I'm a very pro advocate of open source software and an active contributor. And the most active project that I maintain is this encrypted file system. The motivation behind was to create a simple, performant, ergonomic file system for everybody. So to be very secure, be very easy to use, and to use correctly the cryptography primitives. And how it all began. So when I started to run Rust, I wanted the project to keep me motivated, and I asked ChatGPT about some ideas. So we started with the to-do app, which is not so challenging, and then a password manager, a distributed file system, which at that point I considered that it's quite complicated for this. But it turned out that I'm starting to build a distributed file system, and there are others ideas too. And how this originated was that I had a folder with some projects from the work, and I sync it with Resilio Sync. And the idea was to sync it with Google Drive. But the idea was that I didn't want them to have access to my files. So I was thinking that a solution to create encrypted folders would be a very good learning project, and yeah, indeed it was. The Fuse file system is a file system user space, and it helps you to, for example, if you want to expose your files to the file system, and you can access them through the file manager. And it consists of these three parts. So the kernel driver that communicates with the user space library, which is provided by the Fuse project. And then you need to implement your user space. And actually, this is like an interface, and you need to implement all the operations. And in order to learn Rust, I investigated what crates are available, and I implemented an in-memory file system, advantage of learning with smart pointers and and a lot of Rust features. And yeah, I struggle a little bit with the lifetimes, which lately I managed to become friends with. And Rust it's a very good language, so it offers you memory safety. It automatically manages the memory, and it helps you not to have data race, and also reduces the race conditions. And if you come from other languages where you encounter a lot of problems, then you'll appreciate Rust a lot. These are the layer of the application. So the operating system communicates with the Fuse implementation, which uses the encrypted file system core that uses the primitives, the Rust primitives, and it's saved on the data folder. And that folder you can back up, or you can sync with the cloud providers between multiple devices. And this is a quick snapshot of how we save the data. So we have three folders, like contents, where we keep the file content, the inodes where we keep the metadata, and the security is for the key and the salt. The idea of the application was that it should run in a multi-instance, so you can have multiple devices where it runs. And the problem is that in cryptography, you need to be sure not to reuse the nonce. The nonce is a concept of every message needs to be unique in combination with a key. So you need a unique number to combine with the message. And in the multi-instance mode, I need to somehow, in offline mode, generate unique IDs. And one idea how I do this, so for each instance of the application, I allocate an instance ID, which is unique. And then I have some sequence that I keep on each device. And that sequence increases, then in combination with the instance ID, it gives you a unique ID. And this unique ID I use for each file needs to have a unique inode, it's called. And this offers the flexibility to generate some very large numbers. So it reduces the maximum from U64, it reduces to this huge number. So this is how many files we can allocate, which are unique. And the same thing we do for the nonce. So for when I keep the data, and there is a problem. For example, when you have a backup, and if you restore it, you could end up using the same nonce. And in this case, how I solve this is I save the last nonce used, the last sequence actually. I save it in the keyring, also in the operating system keyring, and also in the data folder, and I do a max between them. This ensures that I will never use the nonce. And the limits of how many how much data we can encrypt is this again this full number, so 10 to the 14 petabytes of data. And these are the libraries that we are using. So we are using Ring for encryption, and we think to use Ring Crypt also, which is pure Rust. And it helps when you want to compile to, for example, WASM and Android. And for simplicity, we generate a key based on the user password using Ergon2. And we use the safe cryptographic primitives like we use authentication encryption, which is the AAD, and we use CHA-20 poly 1305 and ISC, which are very well known. Actually, these two are only accepted in the TLS 1.3. And it's very important to keep correctly the credential in memory. So you need to prevent them from being moved to sub file, because the sub file could be unencrypted. So for that, we're using mlock. And when they are not used, we use mprotect. And when the variable is destroyed from the memory, we make sure we zero it. We write zeros to it. And also there is an interesting attack. It's called boot attack. So if the attacker gets hold to your physically gets hold to your machine, it can remove the chip, the RAM chip from the machine. It can spray it with liquid nitrogen, and the electrons in it for the few seconds are still readable. And then he can insert it in his machine, and he can do a memory dump. And later on, he can analyze the memory and retrieve your credentials. So in order to prevent this, we try to expire and write zeros in the memory when the values are not used. Given it's an encryption solution, it's very important to keep the user data private. And the idea is that we really want to offer truly privacy, and we want to hide as much as possible. So we want to hide the count in the file name, the file size, all the time fields, the file counts, and any directory structure. So we don't want to give anything to the attacker. And file names is easy because you just pad it to a fixed length and encrypt it, so it's hard to find. And the file content the same, but the file size and the time fields are a bit more tricky, because if one file, a normal file, corresponds to an encrypted file, you can see how many files you have. And you can see also the size of it, the approximate size. And what we try to do, we split the file in chunks, and each chunk is like an element in a linked list, and we keep the relation between the nodes inside the encrypted chunk files. So we have, for example, you can see in the right, we have for one file, we split it in like 5 or 6 other files. And we also add dummy data to each file, so you cannot know the actual size of the file. And also the number of files you don't know, so everything is hidden from the attacker. And also he is not able to find the full directory size. So for that, given that we have this dummy data, this could increase the space usage. So we make it with parameters so you can define your privacy level. And given that we have these files, it's also for us a bit tricky to how to resolve the root nodes. So for that, we keep them in an index file, which is encrypted and it's not easy. It's not accessible to the attacker. So here we see an example of how you should correctly encrypt files. So it's very advantageous to split the file in chunks, because then you can have the ability to quickly seek inside the file. Just imagine you have a video or something, and you want to quickly seek in it. And then for the safety, there are some considerations that you need to keep in mind. So an attacker could, for example, move the chunks inside the file, so reorder the chunks, which is problematic. And to avoid this, we include in the additional data. So additional data participates to the signature of the file, and we include the chunk index. So if the attacker switches the chunks around, we can quickly detect it. And also, not to be able to move the files between the files, we include a unique ID per file, which also helps when you check the signature. And when we want to ensure the file integrity, there's a problem that can arise. For example, if your process dies while writing the chunk to do this, the chunk remains corrupted. And to resolve this, the database is used this concept of write-ahead logging. So the idea is that you first write to all files, and then periodically or at the end, you write to the actual file. And if the process dies, then when you resume, then it continues to write, and like this, it's ensured that at the end, for sure, you end up with the integer file. And you can see below how a block will be structured on the disk. So we need the nonce, enable to decrypt it. We need the ciphertext, and we need the tag. The tag is like a signature that's used to check if the file was corrupted. And for additional data, we use the file ID and chunk index to eliminate the case when the user would move the chunks around. So this is the tech stack. So everything is built in Rust, and we use fully concurrent operations. Use Tokyo and Fuse 3, and we use well-known cryptographic primitives, and also libraries for managing the credentials and so on. And these are some key features of the application. These are quite many features here, but for some of them we discuss. One interesting one would be that we offer an abstraction layer, so you can have an application that normally access with the Rust API, the Rust file API access the files. For example, you have a configuration file, and you can switch to using our abstraction layer. So you just change the use statement, and it will use encrypted files. So it will write to encrypted files. So like this, for example, you can build password managers or encrypted nodes or stuff like that. These are some stats of our repo. So it all started as a learning project, and then later on I keep adding features to it. And at some point I decided to ask on Rust communities if someone wants to get involved and contribute to open source projects. And for my surprise, we we summed up to like now we are 33 members. So we all contribute to this for open source, and we are divided between some of us are developers, but we have also QAs, designers, and on the trade side you can see we have 19K downloads, and it managed to be the crate of the week in August 2024. Of course, there are other alternatives, some are more mature ones, but we investigated a bit what others have in comparison to us. And it seems that all the features that we offer, there is no other solution out there which has all the features. So they have few of them, others have other of them, but there is no solution that have all the features. So you can see at the link, you can see all the full list of features. These are some references that maybe will help you. There is a link there from a blog with Andrea Corbellini, which is a very brilliant guy. He knows a lot of cryptography, and from time to time when I have very complicated problems, I contact him, and he's very helpful and with links and so on. So we'll have a quick demo to show how the application works. Can you hear me like that or no? I start the application and then I take the link. I'll try it. It's so slow. Okay. So for now, it's a CLI, so the command in application, and we have also a GUI for it. But we're focusing now on getting this table, and then we focus on the GUI. So when we started, it prompts for a password, and given that we already started before, it only asks the person and creates the key. First time you started, it asks you to confirm the password too. And the folder is presented like this in the operating system. So you can see it here, and then you can use it like a normal disk. Let's say we create a folder, go to it, and then let's copy some files. Let's copy this one. Okay, so the speed is slower than you copy a regular file because it needs to encrypt and so on. And we can start the movie, for example, and you can see, for example, we can seek, so we can seek any position we want. Also, we can do quickly seeking, so it works just fine. And normally you can access the files here, so it also works with operation in parallel. So you can have like a BitTorrent, which writes to different parts of the file, different chunks. You can have multiple processes using the file system, so it should perform this. So now, if you have some questions, open for questions. Yeah.
So I think it said that if you didn't store it, it says that if someone reordered chunks,
yeah, it is a problem, and normally, if you don't use this signature with the chunk index, you cannot detect it because it can enter the ciphertext to the encrypted value, but you don't know what the value should be because binary data, so it could be anything, you know, it's like a movie or it could be anything, and you don't know that it happened. So in order to prevent that, we do like a signature, and inside the signature, inside the hash, we include the chunk index at the encrypted time. And when we decrypt it, we will use the same index that we increment. And if they change it, then it means the block is at a different position and the signature will be different. And we catch that. Yeah.
Sorry, I'm beginning. So my question is, what do you use as a backend for this?
It's the purpose of this is not to offer you the backend synchronization. So,
How do you store the actual data?
No, it's files. So I store directly on the disk.
Radu, la prezentare.
So
Am răspunde la...
one real file.
Văd că o reprezentam mai repede.
Let's say one chunks, and
Acum e la întrebări.
each chunk has a different file.
O prezentat, nu știu, vreo 17 minute și lăsam o fi stabilit de comun acord că mai bine să răspundă la întrebări de timpul scurt. Dar acum răspunde la întrebări, de la vreo 4. Da.
To be able to determine how many files we have and the approximate size. And then we also add dummy data. So each chunk will have some dummy bytes, which we ignore. And also we will have dummy chunks.
Trebuie să ne grăbește 10, cel puțin 10 minute.
Sure.
Nu știu cum l-am fixat dimineața.
Yeah. Multiple instances of application. Yeah. So the idea is that in most of the cases, how the use case was thought is that you run this application on your laptop, and for example, and on your phone. And these two devices could be, let's say, could be offline also. So they cannot create a connection to each other. And why it's relevant is because we need to ensure that we need to generate some unique IDs in this offline mode. So we need to make sure that we generate these unique IDs. And for this, we assign each ID is a combination between an instance ID, so each device has a different ID, and then we have a sequence for each device. And then this combination, it creates a unique ID, even in offline mode. Good. Yeah.
Would run this on a program? I was wondering if there's any way to, how would you do that? Know that, well, like it doesn't have to limit space, or it's the drivers, or it's, you know.
So you mean how does it work on the network?
Yeah.
Yeah, so for now we are using the Fuse implementation to make it available in the operating system. The Fuse implementation for now it's only working on Linux, and also there is actually a pull request that is over and need to integrate it, and it will work also on Mac OS, but not on Windows. And on Windows there is some abstraction that is similar to Fuse, but it's like a different implementation that we need to do like a wrapper over our platform. And on the mobile, there is no Fuse there. So on the mobile, we will use actually the picker, the picker that it shows. So when we want to select the file, we'll present via content providers, we will feed with the content and the files and so on. So you actually could pick the file and then feed the content. And all this does the decryption on the fly. So we don't store any decrypted data on the disk or anything. So all it happens on the fly, only in the memory. And it will also, the plan is also to include it in the WASM. So in the WASM, normally we have some limitations, so you can only access the local storage. So we'll keep the files in the local storage, and maybe we can have like a mini browser So you can see the files there, and you can interact with them. So, the plan for the long term is to finish the UI, and then we can have a client ready solution. So now we are working on the core to have it. So we are working actually towards our first stable release. So we have some issues that we are aware of, some known issues, and we have solutions of how we are to implement it. And after we have this stable release ready, then we will focus more on the GUI application, and then it will be a customer ready application. Then, yeah. Go ahead.
How did you find this? This is important.
How did I find it?
Find that.
For now we don't have any monetization. So for now we just work for as a learning project. The plan is to, after we have the GUI, we want to target the regular user who has some private files that he wants to keep private. And then the idea is to somehow get to do the business at the enterprise level. But for that, it's a bit more complicated because one problem is for the regular user, it doesn't care so much if your solution is audited or reviewed by third party that are trusted. But for enterprise, even if they will not care, they have audits and they have policies that they need to respect. So they need to work only with solutions that are audited. So we need to do an audit in the end, which is very expensive actually. We interacted with the company, asked for a quota, and it's in order of many tens of Ks of USD. Actually, it's more than 100K. Yeah. That's a bit more expensive.
It's not possible yet to keep current traffics.
Okay.
Probably a year
Then if it's not possible, then there are no enterprises who ask it if it's not possible to do it. Yeah, so if you go to the repo on the link, there is a label good for first issue, and there are actually I think more than 20 maybe. So yeah, you can take from there. And there is a Slack channel, so feel free to join the Slack, and feel free we can discuss, and we do code review, and it's a collaboration there. So yeah, feel free to get in touch. We actually are glad if you have collaborators. So like for me, I was very impressed that I managed to get to a team of 33 people. So the company that I'm collaborating now with as a full-time job, we are 25. So this is very impressive for me. Okay. Thank you very much. Thank you.